Hey everyone, welcome back to Thermal Guru. Today we are diving deep into one of the most confusing but important parts of RTD sensors, the 2-wire, 3-wire and 4-wire connections. You'll learn how these wiring methods affect accuracy, why industries prefer 3-wire systems, and when 4-wire is a must. So, let's start simplifying RTD wiring. Basic concept of RTD wiring. An RTD, resistance temperature detector, measures temperature by sensing the resistance change in a platinum element, usually PT100 or PT1000. Here's the formula used. R is equal to R, 1 plus alpha T, where R is the resistance at 0 degrees Celsius. Alpha is the temperature coefficient. For platinum 0.00385 omega degree C. T is the measured temperature. When the temperature increases, the resistance increases proportionally. But here's the tricky part, the lead wires that connect the RTD to the measuring instrument also have resistance. Even a small resistance from long cables can create significant errors, especially in precise measurements. That's why we use different wiring configurations to minimize or eliminate those lead wire effects. To wire RTD. Let's start with the most basic, the 2-wire RTD. It simply has two leads, one connected to each end of the RTD element. When you measure resistance, your instrument actually measures the total of RTD resistance plus both lead wire resistances. That means if each wire has 1 ohms of resistance and the RTD element is 100 ohms, PT100 at 0 degrees Celsius, the total reading becomes 102 ohms, which is already a big temperature error. Advantages: simple and low cost. Easy to connect and install. Disadvantages: high error due to lead resistance. Not suitable for long cable lengths or precise applications. Typical use: short distances, room temperature monitoring, HVAC systems, and places where small errors don't matter. 3-wire RTD. Now comes the most widely used, the 3-wire RTD configuration. It adds a third wire, so one side of the RTD element has 2 wires and the other side has 1. This setup allows the measuring instrument or transmitter to compensate for lead wire resistance automatically. Here's how it works. A small excitation current passes through the RTD. The instrument measures voltage drops across 2 paths. Assuming all 3 wires are of equal resistance, it subtracts the lead resistance effect mathematically. Advantages: great balance between accuracy and cost. Works well in industrial process control. Compatible with transmitters and PLC systems. Disadvantages: slight error if the wires are not perfectly matched in resistance. Requires special instruments that support 3-wire measurement. Typical use: process plants, machinery temperature monitoring, and automation systems. Pro tip: for best results, always use equivalent wires and the same wire gauge for all 3 leads. 4-wire RTD. Now for the 4-wire RTD connection, the most accurate and professional configuration. It has 2 wires for current and 2 wires for voltage measurement. In this method, the voltage drop across the RTD is measured without current flowing through the sense leads, so lead resistance has 0 influence on the measurement. Advantages: highest accuracy. Eliminates lead wire errors completely. Perfect for laboratories, calibration setups, and scientific measurements. Disadvantages: more expensive. Requires 4-wire instruments. Not practical for everyday field use. Typical use: calibration labs, research facilities, and high-precision temperature control systems. Example: A 4-wire PT100 sensor is used in temperature calibration baths and scientific test chambers where even a 0.1 degrees Celsius error is unacceptable. Comparison and practical examples. Let's compare all three side by side. Real-world tip. For industrial use, 3-wire is the best choice. For precise lab work, always use 4-wire. Avoid 2-wire when accuracy is critical or when cable length exceeds 2 to 3 meters. Wire materials and installation tips. Always use copper extension wires for RTD connections because copper has stable resistance characteristics. Keep the junctions clean and well insulated and avoid long wire runs wherever possible. If you must use long cables, go for 3-wire or 4-wire configurations to maintain accuracy. So that's the complete explanation of 2-wire, 3-wire and 4-wire RTD connections, how they work, where to use them, and which one gives the best accuracy. If this video helped you understand RTDs better, don't forget to hit like, subscribe, and turn on the notification bell for more awesome videos from Thermal Guru. Thanks for watching and see you in the next video.